Hi, this is Dr. Goldstein, and I am going to discuss even and odd functions. So the definition of an even function is that for all x in the domain of your function, if you plug in minus x to your function, it simplifies back to the original function. And the definition of odd is, for all x in the domain of your function, if you plug in minus x, it simplifies to the negative of your original function. So the thing that both of these definitions have in common is the answer to this question: what happens when I plug in minus x to my function? And if either of these very specific two things happen, either you simplify to your original function or you simplify to negative your original function, then we say that the function is either even or odd. So here are two basic examples. If I start with my first example, f of x equals x squared, and I plug in minus x, so that means that instead of x, I write down negative x, and so I have to square that. And we know that when we square a negative, it becomes positive. And so when I plug in minus x, it simplifies to x squared, and that is equal to my original function. And so that means because f of minus x is equal to f of x, the function is even. If we look at the second example, f of x equals x cubed, and again we plug in negative x, now when I cube a negative, I get a negative. So overall I have negative x cubed, and this is negative the original function. This is minus x cubed. And so because f of minus x is equal to negative f of x, our function is odd. These two types of functions are where even and odd functions got their name. You can see the first example, we have an even power and we have an even function, and in the second example we have an odd power and we have an odd function. That's not true in general, so I'm going to show you some more examples so that you are careful with these definitions. Even and odd functions do not have the same properties that even and odd numbers do. So for example, let's look at the function f of x equals x cubed plus x to the fifth. Again, our question is when I plug in minus x, what happens? So if I plug in minus x, I have to plug it in for both of these terms. And when I raise a negative to any odd power, the third power or the fifth power, I get a negative. So this function happens to simplify to negative x cubed plus x to the fifth if I factor a negative out from both, and this is precisely negative the function that I started with. So in this case, if I take two odd powers and I add them together, an odd plus an odd is still an odd. And that's not how numbers work, right? If you take an odd number plus an odd number, it's going to be even. For example, 3 plus 5 is 8. That's even. So again, here, because when I plug in minus x, I get negative f of x, f is an odd function. That's the definition of odd, and it's being satisfied in this case. Let's look at another example. So g of x here is x cubed plus 1. So now, if I plug in minus x, I have minus x all cubed plus 1. So again, that's negative x cubed plus 1. Here, this is obviously not what I started with. This is not the original equation g of x. And if I try to factor a negative out, this would be x cubed minus 1. And we see that negative g of x, this would be negative parentheses x cubed plus 1, which is negative x cubed minus 1. So g of minus x is also not equal to negative g of x. So these two are also not equal. So because g of minus x is not equal to the original function, g of x, and g of minus x is not equal to negative the original function, g of x is neither even nor odd. It doesn't satisfy either of the definitions. So the mere presence of an odd power does not mean that we have an odd function. We really do have to go and check the definitions. So most functions are neither even nor odd. It's a really specific definition in order for a function to be even or odd. Let's see another example. So if I look at h of x equals 1 over 1 plus x, and again I want to determine whether this is even or odd, I plug in minus x. So everywhere that I see a x here, I plug in negative x, and so this simplifies to 1 over 1 minus x. And we can immediately see that this is not equal to our original function, so it's not even. If I look at what is negative, the original function, there's a lot of different ways that I could write that, and so I really want to play around with that to see if that is what I have in h of minus x. So I could put the negative sign on the top, or I could put the negative sign on the bottom, and here I have to be careful because I'd have to distribute this. So this is minus 1 minus x. So these are three different ways of writing negative h of x, and none of these are equal to h of negative x. I would need to have two negatives on the bottom. So this is not equal to h of minus x. So what I can conclude from this is that h of x is not odd either. It's not odd. So this function h of x equals 1 over 1 plus x is neither even nor odd because h of minus x is not equal to h of x, and h of minus x is not equal to negative h of x. Okay, so one more example, and then we'll do some pictures. So here's one more example, j of x, and again, I plug in minus x. Here, this is 1 over 1 plus, I'm squaring my negative, and I know squaring a negative makes it positive, and voila. I have simplified, and I get back to my original function. So j of x is even. So small differences in your function can make a huge difference as to whether your function is even or odd. And so you really have to use the definition. You have to look at the entire function. You have to simplify. And sometimes you have to play around a little bit and remember the definitions, remember where you're going. So again, the two definitions. F is even if f of minus x is equal to f of x, the original function, and f is odd if f of minus x is negative, the original function. Okay, let's look at a couple of pictures. Here I have our two easy functions that we started with, f of x equals x squared. Remember, we found on the first slide that this is an even function. And we have g of x equals x cubed. On the first slide, we saw that this is an odd function. So here's a visual interpretation of what exactly is going on with these two functions. For an even function, remember the definition is that f of minus x is equal to the original function f of x. So that means, for example, f of 2 needs to be equal to f of minus 2. It might make more sense if I write that in the other direction. F of minus 2 has to be equal to f of 2. So when I look at my picture and I look at x equals 2 and x equals minus 2, and I look at the values of the function, they're both 4. So this is y equals 4, and this is f of 2, and it's f of negative 2. So this is just one example, but if you think about it a little bit more, this is going to work for every x value. If you take the x value on the other side of the axis, they're both going to have the same y value. And so what that translates into visually is that you have this reflectional symmetry across the y-axis. So if I look at the y-axis in this picture, here's the y-axis, I can reflect my picture over that axis and the graph will line up on itself. So that's what I mean when I say that there's reflectional symmetry across the y-axis. So now let's look at our odd function. So that's for every even function. Even functions have reflectional symmetry across the y-axis. Visually, that's how you can tell that they're even. For our odd function, remember what the definition of odd tells us is that g of minus x is going to be negative g of x. So for example, if I plug in negative 2, this is going to be negative what I get if I plug in 2. So I look at my graph, and here is x equals 2, and the y value at x equals 2 is 8. So this is y equals 8, and this is f of 2. And if I look at x equals negative 2, and I look at what that's equal to on my function, this is equal to negative 8. So this is y equals negative 8, and this is f of minus 2. So f of minus 2, I'm calling my function g, actually. Let me change that. This is my function g. This g of minus 2 is indeed negative g of 2 because it's negative 8. So what we see in this picture, it's a little bit harder to see, but if you think about taking your picture and rotating it 180 degrees about the origin, your picture is going to line up on itself. So this has 180 degree rotational symmetry about the origin, which is the point 0, 0. So the idea behind this, and it's a little bit harder to see, but if I plug in the opposite x value, the negative x value, I get the negative y value. So a point that is in quadrant 1 up here is going to end up down in quadrant 3. I have to take the negative of the x value and the y value. So that is a visual interpretation of even and odd functions. Even functions have this reflectional symmetry. Odd functions have this rotational symmetry. But please remember, the definition of even and odd is what you have to use to show that your function is even or odd. So here are the definitions of even and odd. That is how you show that your function is even or odd, algebraically.